Start recording. Hello everyone and welcome to Handmade here on the show. We code a complete game live on stream. We are in the middle of doing our profiler, which is pretty baller at this point. We're just kind of like cleaning up some interface stuff, but it's pretty neat, all the stuff it can do, and I don't know, I'm pretty excited about it. I feel like I'll probably start using this profiler at work at some point because it's like pretty cool, and I don't really have a good one in our current code base that's at all interesting. So since this one works with multi-threading and it works with hot code reloading and it works with stored data over many frames, it just seems like it's kind of like does everything, and I feel like it's probably something that I should use everywhere because it's pretty awesome. Anyway, today is day 262, so if you want to follow along at home and you're one of the folks who has pre-ordered the game on handmadehero.org, you want to unpack day 261 source code. That's what I'm starting with today. I think today basically what we're doing is just interfacey kinds of stuff, basically getting our profiler to show more of the data that it actually has, because it's got a ton, and we just need to now like add interface to allow us to easily access that data in ways that are convenient when we're developing. So right now when we open it up, you can see that I left it in a frame stack display kind of a thing. That's not really that useful at the moment. So we're going to go in and start working with this today to kind of make, I'm going to make the frame graph stuff, and what I might do, I was trying to think if there was maybe a way to do this. I was also thinking that it might be interesting to make it so that the elements themselves are properly linked at the top level, so that you don't really need to iterate over frames as much. You can always iterate, well, I'll show you when we get in there. But point being, what I wanted to do, we have like a frame bar kind of thing going. What I want to do is make it so that we can see frame bars occurring over time, essentially. And so we did some work yesterday to change the way that we were sort of storing things to make that really convenient to do, and also to allow scrubbing and stuff like that a little bit easier. So what I want to do now is just go ahead and kind of like explore that. And so that's really all we're doing today, is getting that stuff going. So I'm going to launch 4Coder here and get down to business. By the way, I am now using 4Coder for all my editing always. I now no longer use Emacs anywhere. So I'm 100% 4Coder at the moment. Excellent work, Alan. This editor is fantastic, and I have had it crash on me a total of 2 times for the entirety of the time that I have used it, and neither of those times were in work-losing scenarios. So I have literally never lost any work with 4Coder, even though it's like alpha something something something, and barely even a released version of the thing. It's still been like incredibly solid. Basically, the only crash problems I've had is shelling out to build, like shelling out to when I go to like do compiles. For some reason, once in a blue moon, that will crash. Probably due to something fantastic happening with Windows launching the executable for the build or something. But anyway, point being. So I've been loving 4Coder, and if you're not on the 4Coder bandwagon yet, not really sure what to say. I guess you're just using a lousy editor. Sorry. Anyway, let me go ahead and load up the debug system here. And let's take a look at those frame bars, because I had this sort of draw frame bar situation. And what I want to do is make this draw frames bar thing work more like what I wanted, because it wasn't really doing anything that I wanted. I had just sort of started it, and it was not really done because we decided to reorganize the data a little bit. So what happens in here when I grab one of these elements and I come through here and I say draw frame bars, I'm going to pass down one of these stored things. And that's not really what I actually want to pass down for drawing the frame bars. Now, the thing that I was saying about wanting to harmonize this a little bit is what you can actually see here from what we've got in the code. You can kind of see that there's like 2 different paths that have to happen when we're viewing an element that we've specifically picked. Because remember, you can click on an element in the profile and we can say like, okay, the profile is not going to view this element, right? And that's this thing right here, where it gets the GUID. It like uses the GUID to get a particular element it's going to view. And the problem with that is that if that's 0, then we won't get back a viewing element, right? And then we're going to get a different kind of thing back. We're going to get a root node back that came from the frame, And if a root node comes from the frame, then it only has just that frame as the data, I think, right? Meaning it doesn't have, what we want to do, I think, is pass an actual element down to the rendering code so that it can go through the frames that are in there. And I'm not sure, I don't like the way there's this dichotomy, because now these functions have to be like aware of whether they're getting a frame-based thing or not, and it's just like, I don't like that, right? It's going to create multiple paths through the code, and what I'd rather do is like collapse those things so that they can be more unified, okay? And so what I kind of wanted to point out here, and this is the thing that I was getting at when I said, I'll show you when we get there, is that now if you look at the way our things are architected, inside a debug element itself, we now have this sort of sub-concept of frames, right? So inside the debug element, there's a thing called a debug element frame, and that stores all of these events inside it, right? And then those events themselves can have trees inside them, which say like what stuff happened, you know, like children blocks of them or whatever. And so what that means is now our debug frame, this thing right here, is actually kind of redundant, right? And if you take a look at the information that's actually stored in here that we actually need, right? It's really just begin clock, end clock, and wall seconds elapsed. That's it, right? That's all we really would need it to store. And so if we were to somehow make this sort of this concept of frames here that we're actually using, if instead of using the root profile node and attaching it to the frame like this, if instead we just had a debug element that was the root profile node, that could actually serve as the container for all of those profiles, right? And that to me seems like a much more interesting way to go. Now, how would we do that, right? Well, we're already sort of doing it, because when we come in here and create the root profile node, we had to get it from somewhere anyway, right? So let's see here, root profile node. There it is. So here's where we were actually storing that, and you can see when we do this sort of parent event thing, we grab the root profile node, and if that's not there, right, we go ahead and we store one, and we store one by using this null event, right, which basically creates it underneath whatever the element is, like that, okay, which creates it under whatever the element is that we were going to use for everything else, right? But why do that, right? Why not just make an actual debug element at the start that is the actual frame element, and then that element can be the one that they are all stored under, and then instead of ever having this, we just make everything go underneath that. We can, in fact, we can even still store the root profile node here, but we just make sure we still do have a backing element that's always there. So in here, when we actually call the store event thing, instead of this, what I want to do is say, like, there's a debug state profile element, or like root profile element, right? So now, like, every last thing that's stored that is one of these root profile events is in there. And that means we can walk that array, which is going to look like any other frame array. So now all of our frame arrays are going to look exactly the same, and we can always pass down an element. And that unifies that part of the code, which is what we want, right? You always want to look to see if you can collapse things into using the same format, right? The same kind of data. Because the more things that you can have that use the same format of data, right, the less proliferation of code paths you have. And that was what we were trying to do, and have continued to do with the debug system, is just sort of proliferate out to find out what we need, but then condense back down into the smallest possible set of things that does what we need. That creates efficient, more compact code that'll be easier for us to manage, right? Even right now, we probably got too much. And so over time, we just want to compact that down. All right. Yeah. More so than anything else, the best code is less code, right? Like, because the smaller, no matter what you think about clean code or object-oriented or non-object-oriented, all those things, the less code you have to focus on, the better it's going to be, usually, because it's just less to keep in your head, less to test, less to go wrong, right? So just like, it's just good. So what I'm going to do here is I'm going to just introduce a debug element. Probably, actually, I'll put it down where we're storing the frame stuff, right? So down here, we will say debug element, root profile element, and then we'll just create that root profile element. Now this will just automatically work. The root profile element we will have to create when we do our debug startup, right? So when we first create the stuff that we need, which is going to be in debug start when we're not initialized, so like in here, right? When we do all of this stuff and create our, I don't even know what this stuff is. This is all really old code. When we first create all this stuff, I'm just going to say, all right, oops. At that time, I'm going to go ahead and say that the root profile element equals however we create an element in here. Get element from event. Is there a way to create one without getting it from an event? I think there's one for getting element from GUID, right? Yeah. So here's get element from GUID. And get element from GUID, unfortunately, yeah, but see, that doesn't actually create it. Get element from event does actually create it. And since we don't actually want to do any sort of lookup here, and we don't really ever want to create a debug event for it, I'm not sure that that's actually all that useful for us. But we could, if we wanted to. We could still make this work that way, I suppose. And maybe for regularity purposes that would make sense. But the other thing we can do is just pull this code out if we wanted to. Because there's really not that much that we would have to do. Push struct will clear it. Is there any initialization that needs to happen for this thing? There isn't, right? I mean, there's nothing, yeah, there's nothing here, and it's not in the hash. So we would just need to put it in the hash somewhere. Yeah. Well, I guess I'll just do it this way. I don't think this is necessarily great, but it's all right. So if I create a root profile event and then I just say get element from event, debug state, root profile event, parent, and false. I don't want it to do any hierarchy creation nonsense. I don't want it to do add element to group either. What does add element to group do if there is no parent? So that seems a little busted, right? Because it's going to do an insert on something that isn't necessarily there. So I feel like in this case, the parent group thing, it should really do like if there is a parent group. Right? Because we don't want it to like insert if there is no parent group. So that seems like a smart thing to do. So yeah, so the root profile event, that's going to be in interface.h. What I'm going to do here is just be kind of sly. Here's the debug event. We don't need to initialize anything at all, right? The only thing we need to do is make sure that this debug event has a GUID associated with it, and that GUID should be parsable. And so in order to ensure that it's parsable in the same way as everything else, what I'm probably going to do is just use the debug name parameter, right? So I'm just going to say root profile event GUID equals debug name, and that debug name is just going to be a root profile node, or element rather, or maybe just root profile. And so once that's created, then we now have a root profile element that will store everything that we needed. Now I'm just going to let this run to make sure that it works at all, and hopefully it will. I don't know if it will or if it won't. So yeah, that's doing something. I don't like that though. We told it not to add this. Get element from event. I told it not to add, so why did it add? Parent group equals parent. Parent is 0 in this case. So it should not do an add element to group here, right? And it should not do, it should not ever do this because create hierarchy is also false. So I want to just quickly step in and see why it decided to do that. Because I'm just assuming that that is what's causing it. Although I guess technically it could also be because of our code up above, right? Where we do root profile node up here. In theory, it could be because of this part, right? And so when this is calling store event, I suppose that might do something like that with the null event stuff. And I'm not sure about that. Let's see what that will do. So that store event should not be doing any of that, right? That should not be happening. So it feels to me like, yeah, like I still bust. So I'm just going to step in there real quick. I just want to make sure it's not really bothering anybody at the moment. Like we can continue doing what we were doing even with that, but I just wanted to make sure I don't want that to be happening unnecessarily. So here we are about to create that root profile. We'll go step into get element from event. We'll call debug parse name, and then we'll call get element from GUID. This is just going to look through the hash to see if there's anything there. There isn't anything. Obviously, it's the first thing being created, so that's to be expected, or one of the first ones. So then we're going to add it in. We'll copy the GUID out, which is what we want. We will use... well, we won't create the hierarchy. What? What? Parent? Parent? What is the parent getting passed? I passed a 0 there, did I not? What did I do? I just did something stupid, obviously. Obviously. So... ah, it auto-fills it in. Ah. 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 Well, obviously that's a problem. I'm going to hit Shift F5 on that. And I'll be honest with you, I want to see... I'm using my inside voice right now. Okay, there's no need to get upset. There's no need for histrionics here, people. We're just going to make this a very quiet, dignified edit. So really, I think what we want to do here is actually just this. I think that's what we actually want to do. Yeah, that's it right there. All right. So now we're in better shape. So basically what I did was I just said, hey, guess what? The only time this is getting used is for events that should be in the hierarchy and for events that shouldn't. We never actually want to add them to a group when they shouldn't be. That was a vestigial remain for when we were actually using the add to group stuff for profile events, and we don't really want that to happen anymore, I don't think. So I'm pretty sure that that's actually how we would prefer it anyway. So now we can leave it like that. Now that we have done that little fancy pants maneuver, right, with extra pants, what we can do is when we come through the thread interval graph stuff, we can drastically simplify what this has to consider in order to do the stuff that I wanted it to do. And I didn't want to go write it the other way because it just would have been a mess, and now we should be able to write it fairly straightforward. So now what happens is we do this viewing element thing. Instead of ever getting events out of it, which we don't need to do anymore, right? We can just skip that part. instead of ever getting events out of it, we'll just say, hey, get whatever the element is that you were supposed to view. And then if that's not true, right, if there isn't one of those, then we'll just say, okay, view the root element. View that one. This stuff goes away. Goodbye. And now we just say, okay, whatever we're going to draw, we're actually going to draw as an element now, which has all the frames included. So now when we call draw frame bars, what we can do is instead of passing a root node, we pass the viewing element. Okay. So that's good. You know, I hate having so few characters on a line. The things I do for you, stream people, to keep it so you can read it. I can fit like 4 times this text in one of these panels when we have a higher res display. Anyway, consider yourself so very lucky. All right. Well, maybe I'll leave that in there for now. So anyway, when we do draw frame bars, now when we pass debug stored event, actually this is going to be passing debug elements, and this is the element, this is the root element that we're doing. And so now when we come through here, things should go a little smoother for us. Now what we should be able to do is say, okay, let's loop through all of the frames. And for now, you know what? I'm just going to get rid of this at the moment. I'm just going to say, you know what? I don't want this right now. We'll deal with it later. So I'm going to loop through all the frames. Here's our frame index 0. We're going to go ahead and say there's no such thing as that anymore. That's just garbage. Forget it. Doesn't matter. And we're just going to loop through all of the ones that are in our root elements frame set. Right? Easy peasy lemon squeezy. Like so. We also know how many frames there are here because we just know, in fact, I can just make the frame count be this. Like so. Frame count. There we go. And then when we want to get the profile node, it's as easy as just saying, all right, whatever the element is that we're on, we want to access the frames of that. And we just want to get the profile node out of that, right? Because this, remember how this works, right? I'm just gonna pop back here for a second. So we're in one of these things, right? And we can grab out the profile node now of this guy by taking whichever, well, I guess there's multiple events in there, right? So we're going to grab this thing out, and then we want to loop over the sub-events of this thing. So we can go from oldest to most recent, right? Although really, we could also say if we're just profiling one of these, we could profile just like the most recent event. Because if this is kind of a little bit of a now I think we want to do them all. So I think what we want to do, right, is we want to loop over any entries that are in this one that we're viewing. So we just, because if there's multiple, then we want to see them all, right? I think that's true. So what I want to do is say, okay, for each one of these, this stuff I'll have to construct ahead of time, right? We'll do that in a second. For each one of the events in here, stored event equals, let's see, what's this going to be called? This is just the root event, I guess. Just trying to decide whether we loop over it and then do children as well, or whether we just loop over this one. I think we actually just loop over this one. We'll find out in a second. So I think this is probably all we want to draw. All right, so instead of like first child and that sort of stuff, right? What we want to do instead is just loop over the events that have been entered into this element, right? And then if we go down to a sub-element, then obviously we loop over those, right? It would always allow us to do that operation. So in here we'd say, okay, the stored event, that's going to be our root event, oldest event. I don't know what this is doing here. There we go. So we go through this. We say go from the oldest until there really aren't any more. Oh, why did I delete that? That's actually what we wanted. And then we just draw them as before. Now, the tricky part here is just going, well, we need to know what the actual total duration was. And that, I believe, is this part, what we want to do right here. And we're not actually updating that yet. So we need to now have that, we need to actually record that span properly, right? Because we need that particular piece of information as we go. Now, I suppose I suppose that is a little redundant as well. Like, the profile node information stores its individual duration, but we also know, we also have the information about the total clocks that we're sort of saying we'd store here. And let me just draw this out, because it's a little bit, again, I'm just wondering if there's still one way we can make it a little bit flatter. So here's what's happening at the moment, right? So at the moment, we have a debug element. And that debug element is the root profile node. Or I should say root profile element, right? That root profile element has in it a series of frames. Right? And inside one of these, it has a series of events. And this is however many events were stored on this particular frame. Now, we happen to know that for the root, this should only ever be 1, because we only ever keep everything under one stored event, right? But it sort of strikes me as like, since we have the ability to store multiple things under here, I'm wondering, does that actually mean we shouldn't have that extra layer, right? Like, we shouldn't bother actually having... We shouldn't make it so there's only one under here. We should just make it so that all of the events that happen on a frame at the root actually just add themselves directly here. Do you know what I'm saying? And that seems kind of logical to me. So in other words, we would go, all right, up, let's see where it is, in collate debug records. So in collate debug records, when we come through here to do a begin block, instead of saying like if not parent event and like getting the parent from the root, like collation flame root profile node, instead of that we'd say like no, you're always going to add this thing as an event underneath the standard debug element, right? If there isn't a parent. So in other words, this if not parent event thing just wouldn't exist. It just goes away. So if there's an open code block, then your parent is that code block. If not, then your parent event is going to be, your parent event is actually just inside that element, meaning there is no parent element, right? I feel like that works. In other words, this store event right here, you just store it directly in the element. and you don't add it to any parent. So, all right, here's my argument for why I don't think you can quite do that. And the reason is because this chaining is per element, right? So if I have several different types of things that happen during a frame, right? So I've got, I've got like collate records, and I've got, I don't know, whatever they, game update, whatever they are. These chains are actually per one of those. And so I think this actually does have to stay exactly the way that it is, where it's using the profile nodes, and it can't be sort of sucked out in that way. And so when you actually say, hey, we're going to draw a particular set of frame bars here, what I want to do is have it so that I can access all of the frames of something. The problem is the profile node itself, it kind of makes it hard still, even with that, even with making it so that they're all under the same one, so that you can uniformly treat them as elements. It just seems like it's kind of hard to still work with, because that top one is actually not really, it's not a profile node, it's just this sort of container. And so it only will have one thing on every frame. As we look across the frames, there's only one thing in it, which is the whole container. Maybe that's okay. Maybe that's fine. But I guess that's just something to be aware of, right? So as we come through here and we do frame index, right, and we get one of these things, we pull out the root event that we're going for. We actually can make this the root profile node, because this actually would be a profile node. So we can access the profile node like so, do the same things we were doing. I think that still works. And then when we come through here, we can do the root node first child like so. And that might be okay, right? That might be okay. Ooh, not a member of debug element frame. Right. So in here, the only question is, how many of these do we draw? Because there might be multiples. But I think, in general, we would only want to draw one particular one of them. But maybe, like I said, what we would have to do here is we would have to draw all of the instances of it for ones that weren't frames. So what I'm going to do here is just do most recent frame event at the moment, but maybe that needs to sort of be expanded. Yeah. And I probably should look to see whether there is a most recent event as well. If there isn't a most recent event, we probably shouldn't. Oops. Let's make this a debug stored event. So we'll take a look. But like I said, I may have to adjust that a little bit. Okay. So these are the frame bars exactly as I had actually hoped that they would be, right? So as you can see, this kind of gives us now a better idea of what our performance is over time in terms of variability. So it makes it very easy to spot frames where things happen that are unusual, right? You can see the pink bars, which are like asset loading, that have like spikes in here. we don't really have any way right now of showing multi-thread stuff on the frame bars like this. So, you know, they're just going to kind of overwrite the other ones. I'm not sure what the best way is to draw those exactly, but you get the idea. Now, the thing that I was saying is I don't think maybe works quite right at the moment is, say I want to drill down into one of these. So let's like move to here. So here's the actual game update running, right? And if I come through here to game update and I want to see this in more detail, if I click on that, you can kind of see now that we've got game update and render on here. And, well, I guess, I don't know if game update and render actually has any sub, I think it should, right? It's supposed to have some sub stuff. And we don't really see anything on here, right? So we're still, I feel like I'm still, you know, it's still just not quite what I want in terms of getting that code structured so that you can drill down properly. Now, if I drill down again on it, then I actually see the actual bars. Of course, we're drawing so much now that we tanked the frame rate, which is not fabulous, obviously. Oh, poor game. Poor game is drawing too many things. It's okay, game. That's just what happens sometimes. You look inside one of these. Look at all that stuff. Yeah, so I'm not sure how we avoid just having crazy amounts of stuff getting drawn all the time. Like, we don't have much of a level of detail kind of a thing, right, that we can lean on for this. Let's take a look at one other thing here, though. If I go to debug collation, so if I zoom in on debug collation, now we can actually see here is the debug start code, and here's the debug end code, which is kind of fun too. Right? Yeah. So almost there, but not quite there yet. I don't know what else we've got here in terms of stuff we could click on. So this is begin sim. And that's get world chunk. Yeah. So I'm interested to know, since basically that's just a lot of busy work on our part, I don't know that the graphics driver is probably getting bogged down. It's probably because we don't efficiently handle high volumes of primitives. That's not what our render stuff is set up to do at the moment. I also wonder what the difference is between release and regular builds there is. I'm just curious. Because that is something we could speed up if we wanted to. We have tons of room to do that with. So hard to say. Let's see here. So let's see. What was I looking at? I was looking at game update. Like so. So it's still pretty bad, but it's actually quite a bit more usable. So, you know, again, if we wanted to, this probably isn't really too much to draw. We probably could, if we wanted to, actually draw all this. But I suspect what would be better for us is if we just maybe put in some logic to handle things where there's lots of small calls and just show that in some other way, maybe. That seems like a better idea. I'm not sure exactly how we do that, but again, that's kind of what we're supposed to be doing now. All right. So let's keep going here. Let's also make sure that we can still draw our old style. Draw frame bars. I want to be able to draw profile in. And draw profile in will also take viewing element. And then I will go back to draw profile in and say that that takes, well, I'm I'm not actually sure what that will do. That will take debug element, root element, and it will say, I don't know, like, I guess this is just going to draw the current frame always. So it's debug state, most recent frame ordinal. So it'll grab that out there. And since there's multiple events that it could draw, I'm not sure, again, what the right thing is there to do. This is kind of always the thing. We have to think about this a little bit more carefully. But I guess we'll just assume that we're going to draw whatever the first one is. But that's the, like, sort of slightly odd part, is really this should now loop over all of the events, because if there are multiple ones, you want to draw them all, presumably, right? So yeah. But anyway, so we'll take the root event, and we'll say that most recent event is the one we'll draw, and then we'll just say, like, assuming that there is a root event there to draw at all, we will draw it. And to do that, we would just use root event profile node. So here's our old display back. Again, I just wanted to make sure we could still do this display okay. And you know, here's our per frame, you know. And here I can drill down into this one and see, like, kind of all the nonsense we were seeing before, right? And I can see all this crazy stuff it's doing. Get world chunk. Yeah. All right. Okay, so that's all pretty good. That's all pretty good. So I think really mostly what I need to do now is I need to make it so that since inside a particular, if you're just jumping in the middle, right? If you're going into a draw profile and you've got multiple events in a single frame for this thing, and you're trying to draw, like, that occurrence, I guess, like, what you want to do is know the beginning and end bounds for that thing. So, like, you know, if we said, here is, trying to think of what the most logical way is to do this, right? It's kind of a really difficult problem. Let me just kind of explain why. So what happens is, let's say we have something like get world chunk, right? So if we have something like get world chunk, it's going to happen many times a frame. So inside a single frame, here's like frame 0. Inside a single frame, we're going to have, like, many calls to this thing. So here's call 0, here's call 1, here's call 2, here's call 3, whatever. So now in the user interface, if I say I want to zoom in to this call, right? That's kind of tricky because that call is not really a grid. It's just the first instance of the get world chunk call. And so if we went to frame 1, right, there may not even have been a get world chunk call on frame 1, or more to the point, let's say we zoomed in on 3, maybe there were only 2 calls to get world chunk on frame 1, and so now there isn't even one to view, right? So saying we want to zoom in on get world chunk is like a grid-based thing that allows us to always, no matter what frame we're on, we can say, here's what we're viewing. But if we want to see a specific instance of that, there really isn't much of a way for us to do that in a stable way, other than something kind of janky like just show me the 0th call to it or something. So what I'm thinking we maybe should do instead is just do like a pre-pass over it, and maybe that total clocks idea, for example, is a good one. And so what we do is we'd say, all right, let's take the total clocks, and we'll just string these things end to end. Right? So we'll condense all the calls for get world chunk down. And so when you view get world chunk, you can't view just a single get world chunk call. You're going to view all of the get world chunk calls. And we'll collapse them into one like viewable one thing. It's not the world's best idea, right? I'm not claiming that it is, but it's just, I think that's maybe what we should do. And so in order to do that, what I would say is as we go through these and we get profile nodes for them, we can sort of sum up the total duration. And what I could do too is I probably could just get rid of that from here. Because doing a pre-pass over it probably isn't the end of the world, I'm guessing. Because the amount of time it takes to go through them and draw them is going to be the substantial part anyway. But we could also do it during collation, right? That's also totally a plausible thing to do. So yeah, so let me take a quick look at what that would look like. We've got total clocks here, and inside the profile nodes themselves, just want to refresh my memory as to what we're actually storing there. So inside the profile nodes themselves, we just store the duration, and that's in clocks, right? And so what I could do is just say there's a total clocks value for any one of these things that that occurs in here. I suppose that could also be a U32 as well, although I suppose there's no real reason for it, so we'll leave it as a U64 at the moment. Yeah, and I wonder, we're never using the aggregate count at the moment, right? So we could get rid of that as well. And then what we could do is keep all of those in U64s. Because now it's the same amount of space, right? This part right here. We could actually keep these both as U64s as well. Just in case it's long. Now the parent relative clock I think we really would prefer to keep as U64 as well, so I think I'm just going to go ahead and make that happen. And then we've basically got a U32 here that's reserved. So we could actually keep since I expanded it, we could actually keep the aggregate in if we wanted to. We're just not using it yet, so I'm not going to bother. So here I'll just say, might as well keep this at full precision just in case. So let's not actually cast that down anymore. And yeah, so this will actually just not get casted. And I think that's good. All right, so let's take a look here. Next step, I'm almost out of time. So yeah, so next step is to keep those total clocks, I think. Seems reasonable. So let's take a look at total clocks. Where we would do that, right, is when something gets added, when we do a store event, we're adding it into the, wherever the frame index actually is. And so when we do that pull, this part right here, debug element frame, that's actually what we would need to be incrementing. And so I don't know if we have that information at the time of storage, so I think we're probably going to have to reverse look it up, if that makes sense. So this is why I say maybe we want to do it after the fact. I'm not sure, because I'm not sure if it's going to be easy for us to do it. The time when we know the duration is here, so adding the total clocks would mean we'd have to add it here. And I'm not sure, I mean, I guess we kind of know the information that we need, but it's a little inconvenient, right? We don't have the element, we'd have to look up the element again. or store the element. So I think I'm just going to skip it. I think I'm just going to say, let's not do that for now. Maybe that's a dumb idea, but like I said, it just looks a little cumbersome to keep that information. So I think I'm just going to delete that for now. And so what we could do is actually just have a way of computing that, meaning we can spend some processor time to get the same information, and it just be a really trivial routine. So all we would have to do is have something that's like get total clocks, and we'd pass debug element frame, and this would just do, force of habit, debug stored event equals frame, oldest event, event equals event next, and I guess this is just literally regular next, right? And then we would say frame total, or rather U64 result equals 0, result equals plus equals event profile node dot duration, and then we would return that result. So now if someone wants the total clocks, they can get the total clocks relatively simply. So in here, if we want to do the debug profile lining things up like that, what we can do is say, like, get me the total clocks for this frame. Like so. And once we have that, then we can actually loop over these and draw them like as a set. That would be the same. That would happen outside. But then what we'd do is we'd say stored event, event equals root frame, oldest event. This is the exact same loop. Event equals event next. And then in here, the root node of the thing, or I'm not going to even call it root node probably at this point. Also, this can happen out here as well. Is just going to be whatever this events profile node is. This, I guess this actually, all of this stuff actually can happen out here too. Right. When we do debug profile node, we grab out the profile node that's for this event, and then we would draw it. And so the only thing that we have to do now is make sub-rectangles out of this that stack up based on how many of these events there are, right? Or how much the duration is, right? And so what I want to do is take whatever my profile rect is and just subdivide it. So what I would do is say, okay, there's going to be a new rectangle 2, which is the event rect, and that's going to be equal to the profile rect. I'm going to pass that down. At the moment, let me just run this and make sure it works. Just want to make sure this stuff still works okay. And so then what we want to do is, as we're looping over these profile nodes to draw them, what I want to do is I want to change the event rect that we're using to basically like only be stacked up for, to not have any space in between it, right? So the first event rect, and I guess I'll do like min clock or whatever, or relative clock. So the first event rect is going to be at the leftmost edge, and then I want to like advance it every time we go by however much clocks that particular event took. So I'm going to do that. I'm going to compute it every time so we don't end up getting off by accumulation rounding, because these could be very like tiny things happening. So I want the event rect min_x and I want the event rect max_x to be set. And what I want to do is set those based on the profile rect itself, based on its size and relative, the relative clocks, right? So what I want to do is say like profile rect min_x plus profile rect max_x in both cases. And oops. Okay. In both cases, what I want to do is just create sort of that standard linear interpolation. So I want to do basically like a 1 minus t kind of thing. T in both cases. So the first t is just going to be whatever this relative clock is in the parent's total space, right? And we know what the total space is. It's this right here. So whatever the relative clock is over the total clock is what we want. And we want those things to be divided, to divide out. We're losing a fair bit of precision here. And we could do this in double, potentially, if we wanted to try and be a little bit better, right? We could do this if we wanted to. You know, maybe that's a good idea. So since we're just doing one divide, it really wouldn't be particularly expensive on any machine we're deving on to do the divide in double. So, you know, off we go. Excuse me. So once we do that, right, you can kind of see where I'm going with this. We know that every time our min_x the next time through is going to be equal to whatever our max_x was the previous time. So what I can do is make like a next_x kind of a thing. And we would just start that out at profile rect min_x, because we know that that's what's going to be. And then each time through here, we just do next_x equals event rect dot max_x or something like that, right? And then that way we only compute it once, each one of those once. And so this is always next_x. So now we only have to do one of those. We do the divide to figure out where this is going to be on the relative clock, and we go. Now, the relative clock, of course, has to be advanced by however much this event actually is. Like however many clocks it actually took, we want to move forward by that amount. And that tells us where like our sort of new location is. Now we might not have to keep that because we have our parent relative clock in here as well. So we could just use the parent relative clock to tell us that piece of information, I suppose. No, we can't, because that's actually telling us the full spaced out version, which we don't want. So this looks roughly correct. Okay. So I don't actually know that I have a particularly good test case for this, unfortunately, either, which isn't great. But at least we didn't break anything, so that's nice. What I could do, well, you know what I could do? I could go down into the game part of the game and look in here and see if I can like look at a particular one of these, and they should be stacked up on each other. Of course, there's probably nothing actually happening inside them, so that doesn't really help. We should probably construct some kind of a test case to actually view that. But that's, I believe, what we actually want to do. And the same thing is going to be true over here, meaning this we would want to do exactly the same code, basically. All right, I think I'm out of time. So I'm going to go to Q&A. Insobat asked a very provocative question. It said, relationship status, it's complicated for the movement to be its own main function inside. And who can't agree with that? I mean, that's... Doesn't look like Q, so I can go eat dinner, is what that means. I can go eat dinner. Steve Voucher, reasons performance so bad with the new debug view, isn't this still way fewer tries than typical 3D game? Yeah, so just to be clear, I don't think any of that slowness is rendering related. Meaning, like, I'm pretty sure that there's nothing stressing the graphics card there. I mean, I could be wrong, but I would be shocked. The problem is the way that we have set up the render at the moment, we don't have any way of pushing like a huge set of rectangles down in a nice coherent chunk. So what's actually happening for every single rectangle draw is it's like creating a record onto the debug, onto the render group, right? And that is getting shoved down to OpenGL as OpenGL immediate calls, which is then getting assembled into a buffer by the graphics card, which is then like buffering it up and sending it down. It's like, it's gonna be a big, it's really, really inefficient how it's currently sending those down. And so we don't ever see that happening with any of our game code. And the reason for that is because the game is about drawing like sprites. So there's very few vertices and lots of texture, right? That's how that works. And so it's deceptive because then it's like, oh, it looks like the rendering is slow here when we draw lots of rectangles, but it's actually not rendering slow. It's just the conduit is slow because it's not set up for this purpose. And if we wanted to improve that, we actually could, right? We could make a special path just for drawing lots and lots of rectangles, and then it would probably be fine, right? We just have some big vertex buffer, and we'd write directly, we'd say like, begin chunk of rectangles. We'd write all the rectangles into there, and issue them all as one big batch, and then there'd be no copies. We wouldn't need a lot of memory on our debug, on our render group for it either, and that would be fine, right? Boogie0815, will you make the UI immediate mode? The UI already is immediate mode. Dude in Basement 1, will the debug graphing update even if the game is paused? Yes, and unfortunately we don't even turn off debug recording right now, which we're going to have to do. We need a way to pause that. It's one of the things we need to do. Long Boolean, right now the outlines on the profile overlap each other. It makes it a little harder to make out the colors or the change from one to the other. The obvious solution would be to draw them with a slight offset from last each time. But are there any problems with that once the rectangles get really small? I think in general, nothing you do is going to work when the rectangles get really small. So I think most of that is really just about when you have lots of small rectangles, you need to like have a level of detail solution there, which I don't know if we're going to do. But you know, if you were going to try to keep pursuing this to make a really, really fancy system, you would want to do that. You would want to have some level of detail there. Is our current time step code frame rate independent? Will the game simulation run the same at any frame rate? So the current code is well, first of all, there's no such thing as frame rate independent code. Literally, I've never heard of a single thing that's ever been frame rate independent. You are always frame rate dependent, and the question is just to what degree. Right now, I would say we are not particularly frame rate dependent, meaning you could get basically the same results with a fairly wide range of frame rates. However, eventually that would break, right? Because we don't, for example, if your frame rate got extremely low, like let's say 1 frame every 5 seconds, we don't subsample the input at all, so you'd move like in these huge steps, right? And you would never really be able to probably do most stuff, like firing would be hard to do and moving would be hard to do and so on. Similarly, you could, if you cranked the frame rate up so high that the frame time rounded down to too small to actually accumulate any movement, we would break there as well. And that's true of basically every game loop that I've ever seen in any game ever. So usually what you do is outside the game code itself, you cap the frame rate on either end. And you basically say, we're never going to let it run at less than 1 frame a second, and we're never going to let it run at more than, 1,000 frames a second or something. Zen Mystic. Are we going to do the batch way then? No, probably not. I mean, I don't care about this, how fast this code runs at all, right? I just want the profiler there so I can see what's going on with the game all the time and spot problems, so that I'm not like clueless about it. Dude in Basement 1, off topic, have you ever defined structures inside of functions? No, because when I, when I was still changing my C++ and C styles around, you weren't allowed to. That's not, legal. So if you had tried back when I was still, when my coding style, was still in flux, you couldn't do this. That's not allowed. So nowadays you can, and I've never really gone back and thought, do I want to do that somewhere? So there might have been times when I would want to do that, and I just never even think of it because I'm so used to it being illegal. If that makes sense. I don't know why it was ever illegal. Because it seems like the compiler doesn't really have to do any work to make that happen. It's a really basic thing. But I guess maybe for debug information it's a little complicated because now it means you have scoped types, which before you didn't. And for producing code, I can't imagine why it would ever be really any big deal with the compiler at all. But for debug info, I guess it does make the debug info a little more complicated because now your types have to be linked to the scope instead of them just being global. So. Six degrees of gaming. Is there any advantage to making physics dependent on frame rate other than convenience? Well, generally speaking, if you have a very physicsy game with a lot of fancy physics code going on in it, typically you want to lock that down to a predictable time step because physics can be very time step sensitive and you don't generally want to run at greater than or less than the standard testing frame rate. So typically what I've seen games do, if they're very physicsy, is they always run the physics at its given time step, whatever that is, 120 frames a second, let's say, they'll always do that many updates of the physics, and then when they render, they'll just render whatever the most recent one is, or an interpolation between the two most recent ones, or something like that. So a lot of times, what I've seen is games don't want to have variable physics frame rates, and the reason for that is physics is very sensitive to the frame rate, and you really don't want the game to change that much. With a game like Handmade Hero, where it's not about like lots of complex physical interactions between like 3D rigid bodies and other stuff like that, you can typically make the game feel roughly the same within a pretty wide tolerance, from like 15 frames a second to 120 frames a second. The game will still, the behavior of the game in general will still be roughly consistent by just using basic techniques. But that's not true of complex physics usually. They tend to diverge quite a bit. So. All right. I think we're done here. I think we are done here. I'm gonna wrap it up. Thank you, everybody, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along with the code at home, you can always pre-order the game on handmadehero.org, and it comes with a source code, which I update every night for your experimental pleasures. Sounds a little weird when I say it that way. Anyway, we also have a forum you can go to ask questions, a Patreon page if you want to support the video series, and a tweet bot, which tweets schedule at you if you want to know when we're going to be live, and we are going to be live 5 p.m. Pacific Daylight Time tomorrow for the last stream of the week. You don't want to miss that. I think it's the last stream of the week. It's Friday, right? Yeah. Last stream of the week tomorrow. Hope to see you here for that. And if I don't see you here for that, well, I will just cry, and so will everyone else. That's about it for today. I would also remind you that if you want to use the editor we use on the stream, you can type 4Coder into your browser and go to this Patreon page right here, my friend. And if you subscribe to this Patreon, you can get your very own copy. We use on the stream the $5 reward one. And I also pack my config file into the Handmade Hero source. So if you're someone who's following along with Handmade Hero and you want to switch to 4Coder, just look in the MISC directory of the Handmade Hero source. It's got it in there. That's about it for today. Have fun programming, and I'll see you on the internet. Take it easy.